Voice clear? Fully audible? No problem? Everything okay? Okay, I'll reduce the fan slightly. It's showing 6 actually. That's up. I come to most powerful. I am seeing not many. Just I am seeing 1 or 2 live. If you continue this way, not coming live, remember, as I told earlier, as soon as SFD&BMD part is over, today overhanging part, after overhanging part, today and I will discuss some important principles, very important principles, then go to cantilever. Once I finish cantilever, I am going to next chapter, that is the most powerful in the design field, bending and shearing stresses. Majority of people does not have good idea. That I will not continue in YouTube. I will continue in the respective, my usual class only. If you can't come live, I know so many are watching the class, but at least I am not going to repeat once again now. I will silently tell last class of SFD&BMD. Now live will stop. From tomorrow, come in Zoom only, once again. Okay, see. First, make a note. Very, very important concept. This has got 2 parts. This all you have to write. You have to make a fair copy. What we are discussing today is very, 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 very important. It has got lot of concept and it has got 2 parts. 2 parts means, I will tell you what are the 2 parts. First part, we discuss different possibility of bending moment diagram. Second part is a unique part. That is, as I told earlier, the maximum sagging and maximum hogging are made equal. That is the most economical proportioning of the overhang and span. Okay, leave it now. Now, first common part. See, whether you go for, there I told 2 parts are there. For common part, that much if you are not knowing, don't come to my class. I told 2 parts are there. If I write common part means what? For both of them common. Means when I go to second, first I will take up the first part now. When I finish first part, I will go to second part. When I go to second part, I won't write all this once again. I told common part. So I will tell you up to where common part will be there. So first go through common part. See. First common part. Consider a simply supported beam, SSB, with equal overhangs on either side. See, it is always should be equal. These principles you cannot derive for random overhangs. Why? If random overhangs are there, then what happens? You can draw SFD&BMD, but this logic is not used. And equal overhangs on either side, subjected to UDL on entire length. See, not I told entire span between support, entire length as shown. See the sketch here. What I will do is, see, A and B are the supports. A and B are supports, means simple supports. Supports. And C and D are left and right extreme ends. Extreme ends. I always want support A, B, extreme end C, D. Sometimes in the bookwork they can give A, B, C, D. Don't tell, sir, in the class you told A and B support. In exam they told A, B, C, D. Leave it. You are not fit for learning then. Should not by heart A, B, C, D. Over. Then, see further. Small L and capital L, both are there. Important. Now, usually people define the span first. Span means, see, suppose there are 2 columns are there or 2 walls are there. Beam is placed. So, small L, in my class, some people take capital L. Again I told you, should not by heart symbols. In my class, small L is distance between supports. That is this L, AB. Or we have small AB equal to small L. Then, or we can call simply supported span. You can call that way also. Simply supported span. Forget the overhang. Or length between the supports. Length between supports. Or for what length the beam is supported at both ends. Over. Then A stands for overhang on either side. Remember, when I go to deflection chapter, I don't take A because there A means something else. One standard formula is there for eccentric point load, A from left hand, B from right hand. So if I take here also A, it will get mixed up. So there what I will do is, in the deflection, I take S, some other symbol. Usually S. S means some symbol. Some symbol required. Anyway, do not by heart symbol solve. Okay. A is the overhang on either side. As I told, equal overhang. A and A. Now, capital L stands for total length. That is from left extreme end up to right extreme end. Therefore, remember, your capital L equal to, see correctly now, I don't know, up to where board visible. I have set for some length. In case when I write, if I go out of board, tell me immediately. So make a note. I will not repeat again and again. My class is meant for those who are serious, not for time passers. Therefore, you can tell, looking at the sketch, your capital, see, you can have two options now. See, two options. If you take between supports as small l, overhangs as A, each either side A, you can tell your capital L equal to small l plus 2 times A. Or, that is, if you know the span, if you know the overhangs, you can get capital L. Or, for some reason, capital L is known. Then you can tell, or then they will tell you what is the overhangs, how much is span. Or you can also tell L equal to, see, this L equal to capital L minus 2A. You can see here only, when capital L is L plus 2A, small l equal to L minus 2A. Remember, this I will not repeat. For some reason later, I may replace capital L by L plus 2A or small l by L minus 2A. Whatever I want, I will do. Okay, now, further, only UDL. Remember, this theory is discussed only for UDL. Reason, most of the building, when you have a beam, it supports slab. Slab load transferred to beam need not be always UDL. Remember, in RCC you will be knowing, it can be triangular, it can be trapezoidal, or it can have varying intensity. There can be point load when secondary beams are resting on main beam. So many possibilities are there. They all, if it comes, you go for SFD&BMD. You don't discuss this theory. This theory is standard case. When, see, most popular, suppose some point loads are there at intervals, or if varying load is there slightly, sometimes people what they do is, if the variation is not too much, they replace by equivalent UDL. So, usually when you discuss some bending, deflection or bending, etc., most critical definition is UDL. So W stands for intensity of UDL. See, W per unit length. What is intensity? I will not tell. If you are not knowing, this is the right time to leave the class. If you ask, sir, what is that unit length? Who knows? I talk that way only. Who knows? Class number 110. Know it? 110. You are asking me now, what is UDL? Over. Intensity. Over. Now see. Now, see, some will laugh. Irrespective. IRR. But I write irrespective. Means just for fun. Someone can comment, he does not know English. I know quite good English. I know quite good grammar also. This is to stress the title, irrespective of. See, sometimes you tell, small. Why that way? Small. Little. So in that case, that means you are stressing it. So, irrespective of means I am stressing it. Of relation between A and L, either A and L or A and capital L. See, you can connect small l with capital L or small a with capital L. Anything, whatever you do, irrespective of relation between, some will ask, what is the relation? Wait for some time. We are discussing that relation only. So it is too early now. Later you will get some relation. So whatever that is in one part and second part, part 1 and part 2, two different concepts are there. In both the concepts, we are discussing relation. Therefore, whether it is for part 1 or part 2, irrespective of relation between either A with small l or A with capital L, your vertical reaction at A will be equal to vertical reaction at B equal to total load on the beam divided by 2. Tell the reason. Reason. Why? Reason. Why vertical reaction at A equal to vertical, whatever is the span. It can be a case of small span and huge overhang, or small overhang and huge span between supports. Whatever is that one, your VA equal to VB equal to total load on the beam, entire beam, total load on entire beam divided by 2. Tell the reason. Why? Reason first. What is the reason? What is the reason for that one? Some reason should be there. Why? Due to symmetry. That is, you write here. I won't write. Why? If you cannot write and later ask the doubt, you are not fit for learning from me, right? Because of symmetry. Sometime or equal to C, total load. W is the intensity into entire length. How much? A plus A, that is 2A plus L. So A plus A plus L. I don't use capital L. There is a reason for not using capital L. Because when you solve the problem, we want small a and small l. Capital L comes later. So A plus A, 2A plus L. So W into total length divided by 2 or equal to C. W into 2A by 2 is WA plus WL by 2. Now, very important. I will write WA plus WL by 2 is reaction. But for some reason, I may write later WL by 2 plus WA. Reason I will tell in the class. Both are same. Instead of writing 2 plus 3, I may write 3 plus 2. See, when you write WA plus WL by 2 or WL by 2 plus WA, there will be some meaning. Some meaning will be there. It is not for fun. Okay, I will tell what is the reason. See, correctly. Observe. What is the reason now? You can observe. This I will remove now. This all I will remove. Not required now. This everything I am going to remove. Okay. See, now, if I put the, see, now I will draw sketch once again. If I write the reaction VA and VB both as WA plus WL by 2, here also, WA plus WL by 2. There are some people who will comment. Both are same. I don't know what you want to tell. I will tell you don't know concept. That's all. See, if I write that way, what it means. See now, I will tell you what it means. Simply support beam is here. See, I will tell the meaning of this term. See, you have a overhang here, we have support here and overhang here. Leave it. This overhang is A, this is L, this is A. Correct? Okay, now UDL is there, UDL is there. Only vertical reaction. See, W into A is the total load. Down. Here only one support is there. Whatever load you apply here will come to this support. For equilibrium, W into A down means this reaction is W into A. Here also, W into A down means only one support. WA, no divide by 2. See, if only one support is there, entire load is transferred to the support. If two supports are there, load is shared. Clear now? If only one support is there, like cantilever, all the loads are transferred to support, no by 2. If two supports are there, if symmetry is there, then equally shared. Clear? Clear or not? WA plus WA by 2. Not told, clear or not? See, these discussions have got meaning. It is not time pass basic. You are not clear or not? I told this one now. Clear. Or now you can tell, see here, since it is W into L, each reaction equal to WL by 2 and WL by 2. See, now reaction equal to WA plus WL by 2, here from that side, WA plus WL by 2. If I write this way, it means load transfer to the support is from the overhang W into A plus whatever load in the span, then divide by 2, WL by 2. That is the meaning. Or, I will tell you what is the meaning of other one. See, what is the meaning of other one? Other one means you take first simply supported beam. That's all. No overhang. Span L. If the intensity is W per unit length, reaction is WL by 2 and WL by 2. Whatever total load on the beam equally shared, each support will get a reaction of load of WL by 2 down, so reaction WL by 2 up. Now, but now you put the overhang. When you provide the overhang, even that load also will be transferred here. How much transferred? Plus extra WA plus extra WA. That is the meaning. So, if I write WA plus WL by 2, it means load transferred from overhang plus load transferred from the member within support to a support. Whatever load transferred, reverse is the reaction. If I write WL by 2 plus WA, it is load transferred support from the portion between supports plus extra load from overhang. Clear or not clear? So I can write whatever I want. I will write the way I want it later. Okay. That is meaning. Okay. Now, see now tell me, is WL by 2 more or WA more? Anybody can tell? Here, see when you write here, WA plus WL by 2 or WL by 2 plus WA, is first one more or second one more? Tell first. Is first one more or second one more? First one more or second one more? First. Which one more? You cannot tell. Depends on how much is the overhang and how much is the span. Okay. 1 minute. Suppose this overhang A is exactly equal to, these all you have to write, exactly equal to half the span. Half the span. That means if the span is, you write, in case the span is 10 meter, if each overhang is 5 meter, 5 meter. Okay, tell me, then WL by 2 more or WA more? See, this when you write WL by 2 plus WA, it is actually this much load. This much load transferred to this support. And here also, this much load transferred here, this much load transferred here. Correct? Yes or no? Tell me yes or no. When you tell WL by 2 plus WA means this much load transferred to this support, this much load transferred to this support. No. How? Suppose I told you if A equal to L by 2, how WA is more? How you got it? How it is possible? I told if A equal to L by 2, then how you told WA is more? How you can tell? When A equal to L by 2, how WA is more? I don't understand how you told. In case your A equal to L by 2, then I am asking question. That you cannot tell. A unique case, if your A overhang is half the span, that is, if the between support, if span is 10 meter, overhang is 5 meter, then equal. That means then your WL by 2 and WA both are equal. Now tell me, if your A is less than L by 2, or 1 minute, if your A is L by 2, you can tell how much load transferred from this overhang, same load transferred from the span. Yes or no? How much load is transferred from this overhang to this support, same load is transferred from the span between support. Tell yes or no. I want yes or no. If A equal to L by 2, how much load comes from overhang, same load transferred from that portion of beam between supports. Correct? Little fast. Should not delay too much for comments. There is a reason for telling this one. There is a reason for this one, not time pass. Okay, now. Or, now tell me, if A is less than L by 2, tell me, then WL, first one is more or second one is more? First one is more or second one is more if A is less than L by 2. First, if A is less than L by 2, tell me, first one more or second one more? That is, if the span is 10 meter and if this is less than 5, say 3 meter, 4 meter, etc. Which is more? One more or two more? Then this is more. Means if the overhangs are less than half the span, not full span, if the overhangs are less than half the span, then to the support more load is transferred from what? From the overhang or member between supports. If the overhang is less than half the span, how much is the span? If the overhang is less than half, less than it 50%, then what? More load is transferred to support from overhang, or I do one thing, from supported portion, from the span, or even this also is span only, correct? That's why I don't use the word span. From supported span over. Now, by chance, okay, then this is more. Okay, then by chance, if A is more than L by 2, then tell me, then more load is transferred from where? More load is transferred from, if A is more than L by 2, more load is transferred from, if A is more than L by 2, more load is transferred from overhang. Remember now, by looking only you can make out. Now, there is one crude wrong concept told. People will tell that way. See, 1 minute. I will tell now only. All those who tell that concept from today, don't tell it. It is wrong. See, so many people will tell you this way. A, L and A equal. Okay, now they will put a dividing line here. Then they will tell whatever load here will be transferred to this support, whatever load here will be transferred to this support. Remember, so many are telling. Or I will tell one other way. A simply supported beam, suppose imagine 2 point loads are there. Remember, 60 kilonewton and 60 kilonewton. Some span, say 8 meter span. Some distance, anyway, 3 meter, out of scale. Anybody can tell me what is reaction VA and what is reaction VB. Tell the answer. Without taking moment, 2 symmetrical point load. Reaction VA equal to reaction VB equal to how much? First. Reaction VA equal to 60 kilonewton. 60 kilonewton. Therefore, can I tell this reaction is this load, this reaction is this load? Can I tell that way? This reaction is this load, or load transfer to this support is equal to that load. Load transfer to this support is equal to this load. Can I tell that way? Can I tell that way? Tell me. Can I tell that way? Fast. or I'll take span 10 meter. Okay, I'll take span 10 meter to make more clear. Can I tell that way? This reaction equal to this load, or load transfer to this support is this load, load transfer to this support is equal to this load. Can I tell that way? First, can I tell that way? This is a common mistake. So many high-level people also make a mistake. No, I can tell. Yes, what I told you. I told here also, see, this much, I told you what? This reaction equal to this much load. This reaction equal to this much load. Correct? This reaction equal to this load. This reaction equal to this load. I can tell. Correct? But I cannot tell this load is transferred to this support, this load is transferred to this support. That is nonsense. See, that is nonsense. Telling that this reaction is equal to this load, this reaction is equal to that load. That is correct. Why? 60, 60, 60 here, see. This reaction equal to this much load, this reaction equal to this much load. Correct. That I can tell. But I cannot tell whatever load you apply here is transferred to this support, whatever load I apply here is transferred to that support is nonsense. Why? That means if you tell that way, suppose I apply only the 60 kilonewton. Tell the answer. Is this reaction 60 and this one 0? Tell me. Is this reaction 60 and that is 0? Correct or wrong? Fast tell me. Is it correct? Can I tell? If people tell, if whatever load you apply here will come to this support, whatever load you apply here will go to that support, is a wrong concept. No. It is what happens is, if you apply 60 here, I will tell you, the reaction here is R more 18. This will be 18 kilonewton. This will be 42 kilonewton. Whereas, if I apply 60 kilonewton here, then this will be 42 kilonewton, this will be 18 kilonewton. But if both the loads are simultaneously applied, because of this load 42 here, 18 there. Because of that load 18 here, 42 there. When you apply both simultaneously, 42 plus 18 is 60, 18 plus 42 is 60. Therefore, you can tell this reaction equal to this load, this reaction equal to that load, you can tell. But you should not tell this load is transferred to this support. No, a part of this, major part of this load will come here. A remaining portion will go there. Same way, for this one, major part will come here. Remaining part will come here. That major plus remaining together will be 60. So be careful. If I tell this load comes here, this load comes there, math calculation point of view, no mistake. I have seen so many people telling that way. See, symmetry is there. So remember, this load comes here, that load goes there. What this load comes here, what that load goes there. No. This load comes not that way. It is true, but actually correct. This reaction equal to that load. Clear? This is for finer point. But here, that concept I told, because don't make this logical mistake. That's why I told. Clear now? Don't make this logical mistake. This is called logical mistake. But math, numerically, no problem. Clear or not? Clear or not? The concept is clear. But calculation point of view, total load divided by 2. When you tell total load divided by 2, does not mean that this side load will come here, that side load will go there. It is not that way. It is not that way. It is not that way. Clear? Okay. Now, first what we will do is, we will go for shearing post diagram. See correctly now. Shearing post diagram. Very important now. I will remove everything now and go for shearing post diagram. See, I will draw 3 shearing post diagrams. See correctly. All concept now. If it takes one more class, no problem. Do you want to hurry and finish fast? If you want to hurry and finish fast, then this problem is not required. See, shearing force diagram, I will first draw here. Shearing force diagram only. Now see, I will draw shearing force diagram for three cases. Three cases here. See, case 1, your A equal to A is less than L by 2. Your case 2 is A is exactly equal to L by 2. Your case 3 is A is more than L by 2. Clear? Or you can tell overhang and half the span. Overhang is half the span. You should write if you want. Half the span between support. Overhang is half the span between support. Overhang is exactly equal to half the span between support. Overhang is more than half the span between support. Or make a note. If span is 10 meter, here overhang is less than, how much, tell me? If that between support, if span is 10 meter, this is the case when overhang is less than, how much? When overhang is less than, if the between support span is 10 meter, for this case, overhang is less than, how much? First case, type all the values, overhang is less than. So, bega, type it, my buddy. Overhang is less than. If the between support, if span is 10 meter, I told you, your small L is 10 meter. Then, for first case, overhang is less than 5 meter. Second case, overhang equal to 5 meter. Third case, overhang is more than 5 meter. Or you can tell one thing. If these all, remember, finer points, this is L, this is A, this is A. See now. In first case, if you add the two overhangs, it will be less than the span. In the second case, if you add the two overhangs, it will be equal to span. In the third case, if you add the two overhangs, it will be more than span. Clear now? That also will do. See, maybe span 10 meter. First case, 3 meter, 3 meter. Second case, 5 meter, 5 meter. Last case, 6 meter, 6 meter. Means what? First case is, if the span is 10, overhang is 3, 3. Second case, if the span is 10, overhang is 5, 5. Last case, if the span is 10, overhang is 6, 6 or more. That way. Clear? Yes, okay. Now, these three cases, draw the SFD. I will tell you why SFD. Anybody can tell why I am drawing SFD. And one more thing. Now I will give respect to mathematics. See, I will put it like this. Now see, this is A. This is A. How much A we don't know. This is L. Okay. If someone looks at UDL is W per unit length. I want to write every time. W per unit length throughout same unit length. Okay. Somebody with the mathematical concept. Okay. A. This is VA. This is VB. Okay, now, 1 minute. W unit length. Now, if somebody with the mathematical concept, if you tell him this is L, this is A is less than L by 2, does the figure looks like correct or not? Anybody can comment? Or anybody will tell, okay, respect to mathematics given. Nodi. Idu 10 meter adre, this is not 5, less than 5. Nodi. 10 arda 5. So, second sketch, I write here now, sorry, correct time. Ega. This is A, this is L, this is A. This is the case when A equal to L by 2. L by 2 up to here. How much here? Same here. How much here? Same here. Last case is, sorry, A L A ನೋಡಿ 10 ಮೀಟ್ರು 5 5 5 5 10 5 5 10 3 3 10 5 6 okay. If someone will look at this diagram, will he complain this person does not have mathematical concept, or he will tell okay, he is giving respect to mathematics. Okay, W I am not writing. Clear now? Clear or not? All the three diagrams somewhat to scale, correct? Correct. Okay, now why I am telling, because I have seen people drawing SFD BMD. See, cantilever, they draw BMD. Horrible BMD. They will draw here 30, 60, then 150. Horrible BMD. It will completely, I have seen plenty of such in YouTube all. Feel pity on them. It will completely against the variation. Nonsense it is called. This slope should be always lesser, this should be more. See, SFD will come, it will come this way. See here, as you go this way, shear force decreases, for them slope increases. See here, slope. At this point, this slope and this slope both should be equal. All these things, sometimes, if point out is not there, all these things are called writing something without proper knowledge. I am not telling you mark 30, then take a scale. No. If you want mark this way, give respect to mathematics. 30, 60, 150, 60. Now if you draw, see. You can see common slope here. Now see, this is correct BMD. Have you seen this mistake or not? So many people, even who are high level, they do this way. So that mistake I will not make. Throughout my SFD BMD class up to class number 110, I maintained eyesight scale. That is called eyesight scale. You don't tell this way. I want, see, I am not hungry, give me little, he is very hungry, give him more. I am not hungry, I don't want much, give me little. And what about him? He is very hungry, give him more. You tell, give me lesser, give him more. Kayingbarli, give me lesser, give him more. They are telling hungry, so give me lesser. I am not hungry, give me lesser. See, this way. He is hungry, give him more. ಸ್ವಲ್ಪ respect to mathematics. Okay, now, correct tell me. I told already, reaction VA, reaction VB. Reaction VA, reaction VB. See, why I am telling, because later when I go to BMD, I will not explain this one. Okay, now, I will use red color here for reaction value. You red beku sigala mamu same roga iri. Hey red, where are you? Illa. If I want, I won't get. Ayyo. Okay, got it. Okay, now see, red illa, it's black. Illa gracharane. Yes, got it. Just to identify, highlight here. See, reaction VA equal to, I will write now WA plus WL by 2 for some reason. When I want to explain SFD, I will write WA plus WL by 2. Same here also. WA plus WL by 2. I already told you what? WA plus WL by 2. WA plus WL by 2. You jagana illa illi. VA equal to WA plus WL by 2. WA plus WL by 2. Now, I already told irrespective of the ratio of A to L, reaction VA equal to reaction VB equal to total load on the beam divided by 2. In the beginning only I told, yes or no? So value is same. But see the shape of the SFD now. See, draw baseline for SFD. Draw baseline for SFD. Draw baseline for SFD. Nodi, ಈಗ start. From here to here, come down by WA. ನೋಡಿ ಸರಿ ನೋಡ್ಕೊಳ್ಳಿ ಈಗ. Come down by WA over. Negative. Then go up by WA plus WL by 2. So when you reached here, you have reached only what? WA. Tell me how much further you have to go up. Ayo, this is so simple. Come down by WA, you reach here. Then go up by WA plus WL by 2. Tell me from here how much you have to go up. From the baseline, tell me how much you have to go up. WL by 2. That how much you have to go up is more than this value or less than this value. First tell me how much you have to go up is more than this value or less than this value. First, I am discussing when A is less than L by 2. I want it. Is it more than this value or less? ಸ್ವಲ್ಪ ಬೇಗ ಅಲ್ಲಿ ನೋಡಿ ರಿಲೇಷನ್. I already told you. I want, is it more than this value or less than this value? More. So ಜಾಸ್ತಿ ಬರುತ್ತೆ ಇಲ್ಲಿ ನೋಡಿ. ಎಷ್ಟು ಜಾಸ್ತಿ ಬೇಡ, ಇದೆಷ್ಟಿದು WL by 2. Then from here to here, come down by WL. Therefore, when you reach here, tell me you will be below baseline by how much? When you reach here, you will be below baseline by how much? Tell me. This is WL by 2 up. From here to here, come down by WL. How much? You will be below baseline by how much? You will be below baseline by exactly this value. How much? WL by 2. Correct? Then from here, go up by how much? Go up by WA plus WL by 2. So when you reach here, you have gone up by WL by 2, then you have to further go up by WA. That is exactly equal to this value, lesser. Then come back to 0. Oh, sorry. This is the shearing post diagram. Minus plus minus, sign namista. Minus plus minus plus. Clear or not? Or you can tell one thing now, not our discussion. At the support A, shear force just to left is WA, shear force just to right is WL by 2. Tell me if it is RCC, critical shear reinforcement is for overhanging side or inner side. Both the cases. Stirrups, if you give RCC stirrups, you need more closer for overhanging side or inner side. Stirrup should be closer for which one? ಅಲ್ಲಿ ಬರ್ತೀವಿ ಬಿಡಿ, ಅಲ್ಲಿಗೆ ಆಮೇಲೆ ಬರ್ತೀನಿ. ಇನ್ನು ಅಲ್ಲಿ ಬಂದೇ ಇಲ್ಲ, ನಾನು ಇನ್ನೂ ಓದ್ಕೊಂಬಂದಿಲ್ಲ ಅಲ್ಲಿ ತನಕ. This question, that is here, critical shear force is for the overhang or inner? Inside. Or if it is RCC, maybe if you provide spacing of, for example, say here 150 centered here, say 150 centered here, maybe you may require closer spacing here, then up to some distance, then you can increase maybe 100 centered center. Clear now? Stirrups, this is just to understand. Shear is critical for the inner side, not overhang side. Tell me, clear or not? First. Clear or not? Clear. ಗೊತ್ತಾಗಿಲ್ಲ ಅದು. 80 mm, ಅದ್ಯಾಕೆ 80 mm? ನಾನೇನು ವ್ಯಾಲ್ಯೂ ಹಾಕಿಲ್ಲ ಇಲ್ಲಿ. ಐ ಹ್ಯಾವ್ ನಾಟ್ ಪುಟ್ ಎನಿ ನ್ಯೂಮರಿಕಲ್ ವ್ಯಾಲ್ಯೂ. ಸುಮ್ಮನೆ ರ್ಯಾಂಡಮ್ ಆಗಿ ಹೇಳಿದೆ. ಇಫ್ ದಿಸ್ ಸ್ಪೇಸಿಂಗ್ ಇಸ್ 150, ಸೇ 100. Clear? Okay. Now, come here. Here, shear post diagram. Go up from here to here, come down by WA. ನನಗೆ ಗೊತ್ತಿಲ್ಲ ಎಷ್ಟು ಬರುತ್ತೆ ಅಂತ. WA. Then go up by WA plus WL by 2. So you have to go up by WL by, tell me, how much you have to go up is less than this value or more than this value? Here, how much you have to go up is less than this value or more than this value? Concept means this is called concept. These all to be understood correctly. How much? Eli, how much you have, here I told you how much you come down, you have to go up furthermore. Why? Span side is more. Here, how much you have to go up is less than WA or more than WA? Equal to WA. That is exactly equal. When A equal to L by 2, WA and WL by 2 both are equal. Therefore, when you reach here, once again, this is WL by 2. When you reach here, again WL by 2. It will come this way. Ayo, jaroitu. Bagar, ange, WL by 2. Then again go here. Exactly how much here? Same amount here. WA and 0. Nodi, WL by 2 will be equal to WA. Shear post diagram is like this. Now, suppose it is RCC. Support this side, if the spacing required is 150, here also, tell me, spacing required. If this side, if spacing required is 150, there also spacing required. How much? Tell me, how much spacing required? For shear, if it is RCC, if the overhang side spacing required is 150, that side also 150. Remember, in the E-tab and shape class, this I will show you in my course E-tab and shape. When I go to E-tab and shape, I will prepare a overhanging beam model where this proportion is maintained. One place you can see higher number here, lesser number here. What is that number? I will tell you in E-tab class. It is the area of shear reinforcement per meter strip. Okay, now E-tab will tell you 600 here and 250 here. Here both it will show 480. Here next time it will show overhang side 600, inner side maybe 350, like that. Okay, now here also same thing. Illu ashte. Whatever shear this side, same shear here. So this also should be 150. Okay, now last case. Come down by WA. WA. From here, go up by WA plus WL by 2. Tell me, how much you have to go up is more than WA or less than WA? Because your A is more than L by 2. Tell me, how much you have to go up is more than WA or less than WA? First. More or less? ನೋಡಿ ಆನ್ಸರ್ ಕೊಡ್ತಾ ಇಲ್ಲ ನೀವು. ಸ್ವಲ್ಪ ಸೀರಿಯಸ್ ಆಗಿ ನೋಡ್ಕೊಳ್ಳಿ, ಇದೆಲ್ಲ ಕಾನ್ಸೆಪ್ಟ್ಗಳು. ಇಟ್ ಈಸ್ ಲೆಸ್ಸರ್ ಮೀನ್ಸ್ ವಾಟ್? ಲೆಸ್ಸರ್ ಇಯರ್ ಇಷ್ಟೇ. ಯಾಕೆ? ಬಿಕಾಸ್ ಯುವರ್ WA ಇಸ್ ಮೋರ್. ನೋಡಿ, ದಿಸ್ ಈಸ್ ಯುವರ್ WL by 2. ಹೌ ಮಚ್ ನಾಟ್ ರಿಕ್ವೈರ್ಡ್? ಕಮ್ ಡೌನ್ ಬೈ WL by 2. ಇಲ್ಲಿ ಬರುತ್ತೆ ನೋಡಿ. ದಿಸ್ ಆಲ್ಸೋ ಇಸ್ WL by 2. ಗೋ ಅಪ್ ಬೈ ಸ್ವಲ್ಪ ಜಾರೋಯ್ತು, ಪರವಾಗಿಲ್ಲ, ಜಾರೋಯ್ತು. ಗೋ ಅಪ್ ಬೈ WA. ಅಯ್ಯೋ ಆಯ್ತು ಬಿಡಿ. WL by 2, go up by WA. ಇಲ್ಲಿ ನೋಡಿ, it will be WA here and 0. See, therefore here if you go to RCC, this side spacing and this side spacing will be different. This side if spacing comes to 125, this spacing can go higher, 175. Why? Spacing more means shear post lesser. This way it will come. Or you can tell one thing now, conclusion. What? When overhang is less than half the span, shearing is critical for inside portion or overhang. Tell the answer. When your A is less than L by 2, at the support, shearing is more critical for inside portion or overhang. ಯಾರು ಅಲ್ಲಿಗೆ ಬಂದೇ ಇಲ್ಲ ಅನ್ಬಿಡಿ. ಅಲ್ಲಿಗೆ ನಾನು ಬಂದೇ ಇಲ್ಲ, ಇನ್ನು ಬರ್ತೀನಿ, ಅಲ್ಲಿಗೆ ಬಂದೇ ಇಲ್ಲ ನಾನು. ನೀವು ಅರ್ಜೆಂಟ್ ಮಾಡ್ತಾಯಿದ್ದೀರಿ, ಅಲ್ಲಿಗೆ ಬಂದೇ ಇಲ್ಲ ನಾನು, ಇನ್ನು ಓದ್ಕೊಂಡ್ಬರ್ಬೇಕಷ್ಟೇ ನಾನು. ವೆನ್ ಯು at the support, both the support, critical shear or design shear is more for inner portion or overhang, inside portion. In the last case, tell me, critical shear post, design shear post is more for overhanging side or inner side. In the last case, critical shear post, design shear post is for overhanging side or inner side. In the last case I am telling, last case, here inner portion critical, there. In the last case, which is critical? Overhanging side. In the middle case, unique case, when your overhang is exactly equal to L/2, then tell me which side critical, or you can tell both equal. Design shear post, either side you see, both are equal. Correct? Correct or not? No. In the middle case, when A is exactly equal to L/2, overhang side and the inner side both are equally effective or equally predominant. Yes, over. Okay, this is the shearing post diagram. Remember, therefore, when I draw BMD later for these three cases, for these three cases, when I draw BMD, what I will do is, I will draw SFD like this, because I give respect to mathematics. Or you can see now, see from a distance, if you do not bother about values, is the SFD same for all three cases? Tell me, is the SFD same? Same means what? Shape of SFD. How much more less not required? Is the SFD shape is same for all three cases or not? See? Without seeing anywhere, all three cases, SFD is same for all three cases. Is SFD same? Shape of SFD same or not? Tell fast, yes or no? Shape of SFD same for all three cases. Fast. Shape of you are not answering, yes or no? Yeah. Correct. Okay. Now the SFD is over. See, when I go to next case, when I draw SFD, when I discuss a case, I will remember whether this predominant or I don't require this. The moment I write the condition to the inner mind, I will be knowing which predominant. I don't have to look at the numerical values there. Okay, now, one important. Next, we have to go for bending moment diagram. Be careful. For bending moment diagram, we need bending moment at all standard. You should write everything you have to write. If you are serious, everything you have to write. This will not be given by me in writing. For bending moment diagram, we need bending moment at all standard points. That is A, B, C, D barde illa. That is for all the problems. C, A, B, D. Correct? We need bending moment at C, B, D, C, A, B and D. Tell yes or no? We need bending moment at C, A, B and D. Standard points. Tell me yes or no? Fast. On the yes and back new. I told to draw BMD, you require bending moment at all the standard point. Some people tell salient point. Yenara karkoli. I call standard point. I like it better. I like the word standard instead of salient. You answer it. I need bending moment at all the standard point. Answer it. Comment it. Yes and parvailla. Then I get doubt. Yes. And also, we need bending moment at those points where shearing post diagram crosses the baseline. Tell me, at those points, bending moment is usually maximum, but rare case, time has come. Rare case, instead of maximum, it can be what? I am telling from beginning, never blindly tell where shear force 0, BM is maximum. If someone tells that way, are you sure? Yes. I will prove you are wrong. How? I will give a beam to him and tell this one, now calculate. He will tell, oh, sorry, here it is minimum. Then why you told maximum? You for y to be maximum or also minimum, dy by dx 0. See, if the curve goes this way, maximum. If curve comes this way, minimum. In both the cases, slope is 0. So dy by dx is 0. dm by dx is shear force. This all I told earlier. So bending moment at the points where SFD crosses baseline, there BM is either maximum or minimum. Tell yes or no. Okay, now tell me, in all these three cases, SFD is crossing the baseline at how many points? Tell me, at how many points? SFD is crossing the baseline at how many points? In all these three cases, SFD is crossing the baseline at how many points? At how many points SFD is crossing baseline? All three cases. Same SFD. How many points it is crossing baseline or changing sign? 3 points. You have to locate those 3 points. But of all this one, among those 3 points, 2 points are already standard points. Yes or no? 2 of the points are already standard points. That is support. Tell me yes or no. 2 of them are already standard point. Tell yes or no. You tell yes means I will go further. 2 of them are already located. Standard point. 2 points. But see, if you delay this much, those who are watching later, they will tell this person is not going further. He is waiting like that. I should remove that delay first. No, I am asking, see, you are answering something else. I told 2 of them are already known points. You don't have to locate, they are known point. I asked yes or no. 2 of them are known point or we don't have to locate it. You do not locate a known point. Yes, and only one unknown point is there. One unknown point is there. That point, some name required, A, B, C, D, I will call E. Nodi, E is not standard point. E is a located point. But you don't have to locate because perfect symmetry. See, WL by 2, WL by 2, WL by 2, WL by 2, WL by W by 2, and this reaction is this much load. So shear force here is this load minus this load will be 0. Therefore, for all 3 cases, this point will be exactly where? Exactly at center of AB or center of span between supports or at L by 2 from both supports. You should write. I am not writing. Randomly I am writing. Those who are serious should write. Tell me yes or no. Sufficient for me. Tell me yes or no. I want that much only. Just I want. You don't have to locate. If you locate, someone will be laughing. Directly L by 2. Correct? Yes or no? All 3 cases, the extra point is center. Therefore, you can directly tell, mark here, distance L by 2. This also is L by 2. Irrespective of what? Irrespective of what I told you. Irrespective of what I told. Irrespective of whether what? Irrespective of whether A is less than L by 2, A is equal to L by 2, or A is more than L by 2. Okay. Now, I am removing everything. Now, I will go for bending moment diagram. The concept, ಇವತ್ತು ಮುಗಿದಿಲ್ಲ ಅಂದರೆ ನಾಳೆ ಮಾಡೋಣ ಪರವಾಗಿಲ್ಲ ಇಲ್ಲ ಹಡಿ ಮಾಡಿ ಮುಗಿಸ್ಬಿಡ್ಲಾ ಹೇಳಿ Shall I randomly go and finish this case? If you want, yes means I can finish. Within 2 minutes I can finish. Shall I randomly tell and finish now? So much decoration I have done. Now, anybody wants now randomly to finish? Yes sir. ಯಾರೊಬ್ರು ಎಸ್ ಅಂದ್ಬಿಟ್ರು. ಅಯ್ಯೋ ನನಗೇನಿಲ್ಲ, ಹಳೆ ಎಸ್ ಅದು. ಇಟ್ಸ್ ದ ಓಲ್ಡ್ ಎಸ್. ನಾವು ಸಿ ನಾವು ಬರೀ ನಾವು ಫರ್ಗೆಟ್ ಮರ್ತುಬಿಡಿ. ಫರ್ಗೆಟ್ ಕನ್ನಡದಲ್ಲಿ ಮರ್ತುಬಿಡಿ. ಹಿಂದಿ ಭೂಲ್ ಜಾओ. ಫರ್ಗೆಟ್ ದ್ಯಾಟ್ ಎ ಲೆಸ್ ದೆನ್ ಎಲ್ ಬೈ ಟು ಆರ್ ಎ ಈಕ್ವಲ್ ಟು ಎಲ್ ಬೈ ಟು ಆರ್ ಎ ಮೋರ್ ದ್ಯಾನ್ ಎಲ್ ಬೈ ಟು. ನೋ ರಿಲೇಷನ್. No relation. Forget it. Put a random sketch. Never bother whether overhang is more or overhang is lesser. Never bother. A, B, C. ಹೇಳ್ತೀನಿ ಯಾಕೆ ಅಂತ. D. Never bother. W per unit length. Unit length. This is A ಅಷ್ಟೇ. ಯಾರೋ ಕೇಳ್ತಾರೆ ಸರ್ ಎ ಮೋರ್ ದ್ಯಾನ್ ಎಲ್ ಬೈ ಟು ಎ ಎಲ್ ಅಯ್ಯೋ ಎ ಎಲ್ ಎ ದಿಸ್ ಈಸ್ ಸಿ ಡಿ ಆ್ಯಂಡ್ ಎಕ್ಸ್ಟ್ರಾ ಪಾಯಿಂಟ್ ಈಸ್ ದೇರ್ ಇಯರ್ ಸೆಂಟರ್ ಇ ವಿಚ್ ಈಸ್ ಲೊಕೇಟೆಡ್ ಪಾಯಿಂಟ್ ಅಟ್ ಎಲ್ ಬೈ ಟು ಫ್ರಮ್ ಹಿಯರ್ ಆ್ಯಂಡ್ ಎಲ್ ಬೈ ಟು ಫ್ರಮ್ ಹಿಯರ್. ನೌ ವಿತ್ ಸ್ಯಾಗಿಂಗ್ ಪಾಸಿಟಿವ್ ಐ ವಾಂಟ್ ಬೆಂಡಿಂಗ್ ಮೊಮೆಂಟ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್. BM at C equal to 0. Tell yes or no. BM at C equal to 0. Past tell yes. Time is not there. BM at C, look this side, 0. If you tell yes fast, I can go further. ಯಾರಿಗೂ ಡೌಟ್ ಬರಬಾರ್ದು ಆಮೇಲೆ ಇದ್ದಕ್ಕಿದ್ದಾಗ ಎದಕ್ಕೆ ಸರ್ 0 ಅಂತ. ಲುಕ್ ಲೆಫ್ಟ್ ಸೈಡ್. BM at C 0. ನೋಡಿ ಎಸ್ ಆ್ಯಂಡ್ ಆರ್ ಡೋಂಟ್ ವೇಸ್ಟ್ ಟೈಮ್ ಈಕ್ವಲ್ ಟು ಬಿ ಎಮ್ ಎಟ್ ಡಿ. ಅದು ಮುಗೀತು. ಸಿ ಓವರ್ ಡಿ ಓವರ್. ದೆನ್ ಐ ವಾಂಟ್ ಬಿ ಎಮ್ ಎಟ್ ಎ ಈಕ್ವಲ್ ಟು ಲುಕ್ ದಿಸ್ ಸೈಡ್. ಈ ಕಡೆ ನೋಡಿ ಮೈನಸ್ ದಿಸ್ ಟೈಪ್ ಐ ಎಕ್ಸ್ಪ್ಲೈನ್ ಪ್ರೊಟೆಸ್ಟಿಂಗ್ ಯು ಶುಡ್ ಲೀವ್ ದ ಕ್ಲಾಸ್. ವೈ ನೌ ಯು ಆರ್ ಟೆಲಿಂಗ್ ಸೈನ್ ಕನ್ವೆನ್ಷನ್. ಸಿ ಮೈನಸ್ ಹೌ ಮಚ್ W into A is the total load into L by 2 equal to minus WA square by 2. Correct? Okay. Now, BM at A equal to what? BM at which point? Equal to BM at LA. Don't calculate. Equal to BM at. Whatever A you got equal to BM at. ಡಬ್ಲ್ಯೂ ಏನಾ? ಅಯ್ಯಯ್ಯೋ ಡಬ್ಲ್ಯೂ ಏನಾ? ಬಿ ಎಮ್ ಎಟ್ ಎ ಅದು ಹೆಂಗೆ ಬಂತು? ಡಬ್ಲ್ಯೂ ಎ ಸ್ಕ್ವೇರ್ ಬೈ ಟು. ಏನು ಪಾಯಿಂಟ್ ಲೋಡ ಇದು? ಯು ಡಿ ಎಲ್ ಇದು. ಈಕ್ವಲ್ ಟು ಬಿ. ಬಟ್ ಒನ್ ಚೇಂಜ್ ಇಸ್ ದೇರ್. ವಾಟ್ ಚೇಂಜ್? ನೋಡಿ ಇಲ್ಲಿ ಆ್ಯಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್, ಅಲ್ಲಿ ಕ್ಲಾಕ್ ವೈಸ್. ಕರೆಕ್ಟಾ? ಹಿಯರ್ ಬಿ ಎಮ್ ಇಫ್ ಯು ಲುಕ್ ದಿಸ್ ವೇ ಈಸ್ ಆ್ಯಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್. ಬಟ್ ಹಿಯರ್ ಇಫ್ ಯು ಲುಕ್ ಎಟ್, ಇಫ್ ಯು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಬಿ ಎಮ್, if you look this side, instead of anti-clockwise, it is clockwise. Correct or wrong? Begadi. Correct? Here it is anti-clockwise, but there it is clockwise. Tell yes or no. Begadi. Time illa. That is the only change. At A it is anti-clockwise, at B it is clockwise. Bega. At A anti-clockwise, at B it is clockwise. ಟೈಮ್ ವೇಸ್ಟ್ ಮಾಡ್ತಾಯಿದ್ದೀರಿ ನೀವು. ನಾನು ಮುಂದಕ್ಕೆ ಹೋಗಬೇಕು. ಒಂದ ಎಸ್ ಇಲ್ಲ ನೋ ಅನ್ನಿ. ಯು ಐದರ್ ಟೆಲ್ ಎಸ್ ಆರ್ ನೋ, ಒನ್ ಆಫ್ ದೆಮ್. ನೋ, ದ್ಯಾಟ್ ಈಸ್ ನಾನ್ ಸೆನ್ಸ್. ದಿಸ್ ಈಸ್ ವಾಟ್ ಆಫ್ಲೈನ್ ಕ್ಲಾಸ್ ಐ ವಿಲ್ ಟ್ರ್ಯಾಪ್. ಐ ವಿಲ್ ಟೆಲ್ ದ ಸ್ಟೂಡೆಂಟ್ಸ್, ಸಿ ದೇರ್ ಇನ್ ದ ಆಫ್ಲೈನ್ ಕ್ಲಾಸ್ ಬೋರ್ಡ್ ವಿಲ್ ಬಿ ದೇರ್. ಓಕೆ, ಇಮ್ಯಾಜಿನ್ ಆಫ್ಲೈನ್. ಐ ವಿಲ್ ಟೆಲ್, ಸಿ at A it is anti-clockwise, but B, remember, it is not anti-clockwise. It is what? They will tell, sir, clockwise. Suddenly they will tell, sir, sorry, sir. Why? Ayo, sir, sorry. Then I will tell, clockwise, huh? What I told so much, bending moment. Here it is hogging. Here also it is hogging. Sorry. Further I cannot tell. Now, tell me. Lastly, ನೋಡಿ ಜೋರ ಬರಿತೀನಿ. Lastly, you need bending moment. ಎಲ್ಲಿ ಹೇಳಿ? Bending moment at where? Tell me. Lastly, you need bending moment at ಎಲ್ಲಿ? ಬೇಗ. Lastly, you need bending moment at. Lastly, you need bending moment at ಯಾವ ಪಾಯಿಂಟ್? ಇ. ಯು ನೀಡ್ ಬೆಂಡಿಂಗ್ ಮೂಮೆಂಟ್ ಅಟ್ ಇ. ನೋಡಿ, ನಾನ್ ಸ್ಟಾಪ್ ಮಾತಾಡಿದೆ, ಟೈಮ್ ಇದೆ ಪರವಾಗಿಲ್ಲ, 5 minutes ಜಾಸ್ತಿ ತಗೋತೀನಿ ನಾನು. ಐ ಟೆಲ್ ಥಿಯರಿ ಒಂದು 5 minutes ಬೇಕು. ಐ ಟಾಕ್ ಟೂ ಮಚ್ ಆ್ಯಕ್ಚುಲಿ. ಸೊ ಜಸ್ಟ್ 5 minutes ಬ್ರೇಕ್ ಫಾರ್ ಮಿ. ಡೋಂಟ್ ವೇಸ್ಟ್ ಟೈಮ್. ಯು ರೈಟ್ ಕರೆಕ್ಟ್ಲಿ. ಯು ಹ್ಯಾವ್ ಟು ಗೆಟ್ ಪ್ಲಸ್ ಬರಬೇಕು. ಪ್ಲಸ್ WL²/8 ಮೈನಸ್ WA²/2 ಬರಬೇಕು. This answer should come. You take a paper, substitute here, find bending moment here, either look left side or right side, correctly substitute and get this answer. It should be plus WL²/8 minus WA²/2. It should come. Then I will tell you a logic about this one. Ivattu logic ಹೇಳ್ತೀನಿ. I will tell you logic for all the DMs. Then some extra I will tell. Then we can go for diagram. See, these are all finer points. ಅಷ್ಟೇ. Don't tell ಬಂತು ಅನ್ಬೇಡಿ. ಒಂದು 5 ನಿಮಿಷ. I want rest for 5 minutes. So you substitute in a paper and get this answer. WL²/8 minus WA²/2. For this, how I got is not by calculation. I got it by logic. ಅಷ್ಟೇ. I got it by logic. ಅಷ್ಟೇ. That logic also I will tell. You don't have to calculate. I got it by logic. I will tell you the logic after just 5 minutes break. Okay. 5 ನಿಮಿಷ ಜಾಸ್ತಿ ಬೇಡ. You take your calculator and get the, not calculator, take a rough sheet. Remember now, after I come back in 5 minutes, another 10 minutes required for 10-15 minutes are there. I am going to tell very powerful concept. Remember, very powerful concept. One place, surely you will make mistake. If you do not make the mistake, I will be very, very happy. If you do not make the mistake, I will be very, very happy. Let me see whether you are going to fell to the trap or escaping. Let me see. Small point. I will come in just 5 minutes. 5 minutes I will come. Start. Now, got the answer? Fast. Got the answer or not? If you got the answer, I will tell some logic. Some powerful logic is coming now. If you got the answer, I will tell you some powerful logic. Pen here. If you got it, in one answer. Not getting a. See? Why? If you got it, I will tell some powerful logic. Not getting a. Why? Nobody getting answer? See, no comment. Nobody getting answer. Obtain, then tell no. Okay, see. Now, first to get the answer by basic principle. Then see. Hey, alle kutiru. Parthini. Nodi. Also, lastly, bending moment at the most powerful point, that is E. I will write dark at E equal to, see here. This reaction I told, this reaction VA equal to, now I will write WL by 2 plus WA. Y means I want that way. VB also same. Okay, tell bending moment here. Plus WL by 2 plus WA is the reaction into L by 2 minus BM here. WL by 2 plus WA irrespective of ratio into L by 2 minus W into this total length. Total length is L by 2 plus A is the total load into center of that load is at what distance? L by 2 plus A, that divided by 2. Innodi. WL by 2 plus WA into L by 2 minus W into A plus L by 2 into A plus L by 2 by 2. Tell me, fully clear or not? I will simplify them. You tell me clear, sufficient for me. You should tell clear this step. Then I will tell you the logic. Okay, now if you simplify, it will become WL by 2 into L by 2 is WL square by 4 minus plus WA into L by 2 minus W by 2 I will keep outside. W by 2 if I keep outside, L by 2 plus A whole square, that is L square by 4 plus A square plus 2 into L by 2 into A is 2 into L into A. Or if I simplify, WL square by 4 plus WAL by 2 minus WL square by 8 minus WA square by 2 minus 2 cancels W into A into L. W into A into L positive, W into A into L negative will cancel. Then 1 by 4 minus 1 by 8 is what? 1 by 4 minus 1 by 8 is 1 by 8 or equal to plus WL square by 8. Then only remaining is minus WA square by 2 is the bending moment with sagging positive. Tell me, just fully clear or not? I want that one. Fully clear from basic principle. Then I will tell you principle. Then I will tell you principle. Because these principle all you should learn once. Later you won't get anywhere. Randomly people will tell. I don't think anybody will tell this much details. Or this answer now. Do one thing. Remove everything now. Once again cancel. Start. Fresh now. You consider the left overhang. This is C, this is A. There is a UDL here of W per unit length for a length of A. Now for equilibrium, there is a reaction of WA, and if this is rotating this way, there will be reacting moment here of W into A by 2. This all I explained for you. WA square by 2. This is free body of CA. Then do one thing. Free body of, after CA, write free body of AB. Don't write AB. You tell AB, hey AB, you wait for some time. I will go to right side overhang CD. There, overhang is A, UDL is W per unit length. So there is an upward reaction of WA, and this will turn this way, balancing moment of WA square by 2 over. Now come to the beam between supports. A here, B here. UDL of W per unit length, and there is a reaction here of total load divided by 2. This is L, WL by 2 here, WL by 2 here, and this load and this reaction, both are load transfer to support. That's why reaction came WA plus WL by 2. But remember, this moment cannot be transferred to the support if you apply moment this way. The effect on this member is same couple in this direction. This I explained very thoroughly earlier. WA square by 2 and WA square by 2. Or directly, see here, if you look that way, transfer, a couple of WA square by 2 will come. Now, here your BMD will be like this. Negative, how much? WA square by 2. Here also your BMD will be negative here, WA square by 2. Parabolic. Okay, now here the BMD will be, do one thing, draw the bending moment diagram only due to, first you do one thing, draw the BMD due to simply supported beam without considering couples. It will be parabola of, tell me, what is this ordinate? What is this full ordinate? What is full ordinate? Simply, this is for simply supported beam with only UDL. Tell this ordinate, standard it is. What is ordinate there? Parabola of, how much? That ordinate, parabola of simply supported beam with UDL, no end couple. No end couple. What is the bending moment? At center of span, WL square by 8, positive. Remember, this is positive, full positive. Now, there are two end couples are here. Will this end couple will hog the beam or sag the beam? UDL will sag the beam. So, plus WL square by 8. This end couple will hog the beam or sag the beam. First, the end couple will hog the beam or sag the beam. The end couple, will it hog or sag? It will hog. How much? Here it will hog negative by WA square by 2. Here also negative by WA square by 2. And now you should not see UDL. Just a simply support beam with couple. Constant throughout. Nodi. Wherever you consider BM is this way, negative. Now what you do is, so resultant BM is this much positive, this much negative, or we don't know whether this is more or this is more. Time being, imagine that this is more. Time being, imagine that this is more. Tomorrow we are discussing, if this more, what happens? Now do one thing, fold it on other side. Fold it on other side. How much? WA square by 2, WA square by 2, and fold it on other side. And remember, this is minus. This is minus. Now see, this region, it is a overlap of minus and plus will cancel. Therefore, this will be WA square by 2, WA square by 2. This value will be, how much, tell me? This full is WA square by 8. This is WA square by 2. The resultant value here is positive of WL square by 8 minus WA square by 2. Clear? That's how you got the bending moment here. WL square by 8 is the bending moment, sagging bending moment, because due to simply supported beam with UDL. WA square by 2 is the hogging BM because of overhang. Since simply support beam will sag WL square by 8, overhang will hog WA square by 2. The net value, if you imagine sagging, it is WL square by 8 minus WA square by 2. Therefore, remember, finally you can tell what? Finally you can tell for this overhanging beam, tomorrow you require it. If the overhang is A, if the overhang span is L, if it is A, if it is full UDL, here BM is 0, here BM is 0, here BM is minus WA square by 2, here also BM is minus WA square by 2. With sagging positive, center BM is WL square by 8 minus WA square by 2. Now this is the important point. This much fully clear? First. This much fully clear means, I think 9, 10 now. Further if I discuss now, it will take at least half an hour. So tomorrow I will conclude. Tomorrow I am concluding this one. Day of tomorrow I am starting cantilever. Sure. Tomorrow I am concluding this one with all the principles. Second part is very simple. When for maximum sagging to be equal to maximum hogging, some ratio will come. Here, when A equal to L by 2, this will become 0. When A is less than L by 2, it will be still sagging. When A is more than L by 2, that BM, this will be more, entire beam will hog. So your BMD is tomorrow, it is going to come based on different cases. And I'll tell you now, if your A is less than L by 2, your BMD is going to come this way. If your A is equal to L by 2, your BMD is going to come 0. If your A is more than L by 2, your BMD is going to come this way. Minus, minus, plus, minus, 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 minus. Here 2 contraflexure point will be there. Here 0 will come here. Hog, sag and hog. Here fully hog but center 0. Here fully hog, center bending moment, not maximum. What, tell me? Center bending moment. Not, and here these two cases, the center bending moment, not maximum. Instead, what? First case, it is maximum. Second and third case, it is not maximum. It is what? Tell me. It is not maximum. It is going to be. What? It is going to be. In the second and third case, it is not maximum. It is going to be. First. You tell that one. I will continue tomorrow then. Second and third case, the definition is, it is not maximum BM. It is what? Other than maximum, what is there? You answer it. Okay, if you don't answer, what I can do? I cannot ask you 100 times. Nobody. It is not maximum. What it is? It is minimum. 0 no minimum. Negative badange. It is minimum. It is minimum. I will explain tomorrow the behavior of this one. Then I think I need around half an hour or 45 minutes. Till 45 minutes there, I will go for the special case of the second part. When sagging BM equal to hogging BM, it is very useful when you lift the pile. See, pile is a compression member. It is used inside. It will be a very thin section. When you lift the pile, see, when the pile is lifted, suppose you lift it from ends here, heavy bending will come. So it may break. So if you lift very closer, hogging will come. The position of lifting of the pile is fixed so that when you lift the pile, then that's due to self weight, how much hogging BM comes, they will see that same sagging BM will come. Then if the lifting points are moved further inwards, hogging will increase. If the lifting points are moved outwards, sagging will increase. So unique position for lifting the pile will be around 0.3 will come. 0.35 ಇರಬೇಕು 0.35 with respect to L. Overhang should be around 35% of L. If the span is 10 meter, overhang should be around 3.5 meter. That all will prove tomorrow. Tomorrow is the concluding class for overhanging beam. And then in my usual course in SFD&BMD, I will solve at least 15 to 16 problems, or there will be at least 15 to 16 classes uploading in YouTube. Those who are in BSK batch, this much knowledge, you can one by one, you can study there. I am sending link to you. I will go to cantilever. I think explanation is sufficient. I told almost every principle for SFBM. Okay, thank you. Tomorrow we will meet concluding class later. Tomorrow heading will be concluding class for concept of overhangs. Okay, thank you. ಸ್ವಲ್ಪ ಆನ್ಸರ್ ಬೇಗ ಕೊಡಬೇಕು, ಟೈಮ್ ತುಂಬ ಡಿಲೇ ಮಾಡಬಾರ್ದು. ಲ್ಯಾಬ್ ಐ ಶುಡ್ ರಿಮೂವ್ ದಟ್ ಲ್ಯಾಬ್ ಫಸ್ಟ್.